Raw sewage is basically wastewater. Okay. How come our do we have to answer the conclusion questions? Those 5 questions. That says like the journal questions or whatever. Is that what you're talking about? Yeah, yeah, you'll need to answer those. It's on the rubric. So anytime you have a question about like, is this going to be graded? Is this going to be graded? You can actually go to the Dropbox folder for that assignment, and you can click on the rubric, and it'll tell you exactly. So there's like a data table, and then there's like conclusion questions. If you can't get the glycoside to work right, and so like the DO and that kind of stuff, you can't get it to show up, which I had that problem too. You can go to the news announcement, and you can do that alternative assignment for that part of the data table. So I'll look for that instead of the data table being completed. So if you don't have the data table completed, but you have that stuff, then you'll get full points for that. Wastewater is basically like everything collected from your drains. So that includes like your toilet and your shower and your sinks. All of that is put together and makes raw sewage. It's 99.9% water and just 0.1% waste. But if you've never been to a wastewater treatment plant, I highly recommend that you check one out. It is very, very smelly. And it definitely the water is brown and like chunky and stuff. So even though it's 99.9% water and only 0.1% waste, it's still gross. It's really gross. I went during the summer. It was very, very hot. I don't know that I would recommend doing that because it was really smelly. So what's in raw wastewater? This is supposed to be a picture of raw wastewater. There's debris and grit. So any sort of big things, you can have, you'll have toilet paper, obviously. You'll have like food particles. Um, if you watch the video about the wastewater treatment plant, they talk about like living sticks in the wastewater and like condoms and all sorts of weird stuff. Like things that you wouldn't think that people would flush down their drains or their toilets, they do. And so all of those things are in the wastewater. There's also particulate organic matter, right? It's the stuff from your toilet, so there's going to be, that stuff in there. And then there's some dissolved organic material and some dissolved inorganic material. So, for example, if you spray chemicals or anything like that, that stuff can get down the drain. Or if you see like storm drains, that stuff sometimes goes to the wastewater treatment plant. So all that kind of stuff will all end up in the wastewater treatment plant. So what do they do? So the first thing that happens is all of this like chunky brown water. It sounds really gross. Comes in and it goes through like a screen, and then it goes through these things that like kind of rake. Let me see if I can kind of draw it. There's these things that like kind of hang down like this, like a comb. We call it a rake, and it like rakes up that clunky stuff. Okay, and that stuff is like manually raked, not by like hands, but by this like thing, like that looks like this. It's really long. It goes all the way like across, and it just looks like a giant comb, and it just gets all that stuff. Um, it's actually all the same length. I'm just not very good at drawing things that are the same length. But it looks kind of like that. You can see that kind of right here. Okay. And it starts like pudding. Eventually, like a chocolate pudding. I know it's gross, but um, it is what it is. And so the grit will settle out in the grit chamber. So this is the grit chamber right here. I don't know if you can see where I'm writing. And the grit will settle out at the bottom. It's kind of like if you, let me get a different color. If you have anything, like if you have like, say you're drinking tea and you have like tea leaves, they'll like settle to the bottom. So like if you have your container, all that like grit and chunky stuff just kind of like will settle to the bottom. The stuff that doesn't get removed by the rakes, that's like smaller, it'll settle to the bottom of that container. And then you can see here, right, this part where it flows out is higher than the bottom. So the idea is that all that grit stuff will be down here at the bottom and the water will flow out the top. That's the idea. And then it goes to a primary clarifier tank, and this has the water comes in like in the center here, like you see how it goes like this. It comes in and then it kind of like flows out like this. Um, and then hopefully again, you have that particulates that kind of like settle out in the bottom. And so they'll kind of settle out this way. And then you get that gross stuff, right, the sludge. Okay. And then you've got some water that's supposedly a little cleaner, and it's coming again out the top, not the bottom, because they're hoping, you know, all the gross stuff stays in the bottom. And so that's going to take out a lot of stuff. Then you have secondary treatment. So in secondary treatment, you have that water that's coming from that clarifier, and you put it in this aeration tank, and it bubbles. That's how they add the oxygen. They bubble it. And so hopefully what happens is the oxygen can start like kind of making that an oxygenated environment, and then allow you to like get uh, like oxygen bacteria that needs oxygen. They can kind of start breaking it down. The water will kind of flow over rocks and like percolate through the rocks. So you'd have like, you know, these rocks like this, kind of like in like a fish tank or something, or like outside, you know, where that you've got the water and then it kind of like percolates down through the rocks, and the rocks kind of filters it a little bit. You know, it traps bigger particles up here because it can't fall through the rocks. Um, then you have this stuff called activated sludge. This is like basically bacteria, and so these detritus feeding organisms, bacteria basically, and they aerate the water. Again, the activated sludge needs oxygen. Okay, then I know this didn't cut off like the top of it, but anyway, then you have something called biological nutrient removal that's going to remove nitrogen and phosphorus. So remember we talked about like fertilizers and stuff. If that gets in here, it's going to get those out. And so you can see you're going to go, so anaerobic means without oxygen. So you're going to have no oxygen here. Then you're going to have anoxic, again, that means no oxygen. I don't know why they use two different words for that. And so you're going to have like bacteria that don't need oxygen. Do we need to do that for? No. You only need that data table slash the alternative assignment plus the 5 questions. And again, you would see that in the rubric. You'll see that the rubric will only have that part. It won't have where it needs all those other things. So you've got these 2 anoxic areas where there's no oxygen, and you've got bacteria that does not need oxygen, kind of feeding on all that sludge. And then you've got an oxygen area. It's oxygen rich, so we're going to have yes, O2. And then that's all going to go into this secondary clarifier tank. Okay, and it's going to get extra sludge out. So, you know, kind of some of the things that the oxygen or that the bacteria has decomposed, it's going to get that out. And then we're going to, that stuff's going to go down the bottom, and the clean water is going to come out the top. So that's a common theme if you notice. We've got these tanks where like the bottom holds gross stuff and it's supposed to sink. And then we've got the water at the top. So they're taking advantage of the fact that most of the things that are in the dirty water are more dense than water. So the anaerobic digestion just means without oxygen, which we talked about. The treated sludge or biosolids, that's what remains after the anaerobic digestion. And this has to go somewhere, right? So a lot of times they have to move this to like a a landfill or something like that, there'll be some information that it'll talk about this a little bit in the FRQ for this unit. It'll kind of ask like, okay, now what do we do with all this stuff that we took out of the water? They can compost it. They can add mulch to the sludge. And some places, they will actually they'll sell that mulch, that composted stuff for people to put in their gardens. So you're buying people's poop and stuff, not in raw poop form, but that's kind of what you're doing. And then they'll pasteurize the water, so they'll heat it really high to kill pathogens. A lot of times they'll can use chlorine to kill things, or um, like UV radiation to kill some things in the water. So they'll do that as well. Now, before I get that, when they finish, at least the wastewater treatment plant I went to, when they finish, they the water that they pour out of the treatment plant is actually is better or cleaner than the water that they pulled out of the Coney River. Okay, so what usually happens still anyway is that like up here you would have your water removal system. So like up here they would get the water like during our, we'll call that DW. This is where they would pull drinking water out of the river. And then down here, the sewage treatment plant would put the water back in the river like any, we call this STP for sewage treatment plant. Yeah, you just asked that question. No, you do not have to use it. If you look at the rubric, you'll see that the rubric says that all you have to do is have the data table or the alternative assignment, and then answer the questions. So what you've got is you've got your water coming out here, your drinking water, your water from the sewage treatment plant is coming here. And then you'll see that there, okay? And so they like to say that they have the sewage treatment plant water coming out below the drinking water, and the reason they do that is because people don't want to drink like poop water, right? But somewhere, this river keeps going. In some other town, you're going to have a sewage treatment plant there, right? So they like to say, someone is always downstream. That's what they like to say. So just because in your town the drinking water is upstream from the sewage treatment plant doesn't mean that you're not downstream from some other town's sewage treatment plant, which is why the sewage treatment plants, have such strict regulations that they actually put the water back into the river cleaner than it came out usually. Now, septic systems are something that usually like rural places use septic systems, and so they have some sort of like septic tank in their yard, and what they do is, so like anything that all the water from your house kind of goes into the septic tank, and then it kind of drains into a drain field, and then seeps in. Every like 5 to 8 years, I believe you have to get your septic tank like drained or inspected. And so if you're on septic, which you would know, at least your parents would, you have to be really careful of what you implant. It's going to go to your septic tank. So they, like for example, they don't like to put garbage disposal in houses with septic tanks because they don't want people putting stuff down the disposal. That kind of makes people want to put stuff down the disposal. And so they just don't put them in there. You can get one, but they don't like to. Again, you have to have it inspected and pumped at least every 5 years. And then a lot of times you want to keep heavy equipment or vehicles like off of your septic field. And sometimes like my parents, they had a septic tank and it like something happened to it, wasn't working right. and they actually had to like dig up their yard, and it was this like big concrete like thing, and they had to um, like pry the lid off of it and like look in there, and they had to get someone to look at it to see what was wrong with it, and then they had to like put the lid back on and then cover it up again, and but if it wasn't in the middle of their yard, but if it had been, that would have like kind of messed up their yard a little bit.